Implementation of Meta's Thought-to-Text Decoding Technology in 2024. Introduction. In 2024, Meta is set to launch its groundbreaking Thought-to-Text Decoding Technology, marking a significant leap in the field of artificial intelligence (AI) and enhancing human-computer interaction. This technology aims to allow users to communicate with AI through thought processes rather than traditional input methods like typing or speaking. This report outlines the key phases of implementation: budget allocation, integration with existing AI frameworks, and considerations regarding ethical implications and user experience. Key phases of implementation. 1. Development phase, early 2024. The initial phase involves refining the algorithms of the thought-to-text technology utilizing Meta's existing Llama series, specifically Llama 2. The $5 million budget allocated for this initiative will be instrumental in enhancing the model's capability to accurately interpret neural signals. The development will focus on several key areas. Algorithm refinement, improving the neural decoding algorithms to ensure precise translation of thoughts to text. Data collection, gathering large data sets of brain activity associated with specific thoughts to train the model effectively. Safety protocols, establishing safety mechanisms to protect user data and prevent misuse of the technology. 2. Pilot testing, mid-2024. Following the development phase, Meta will conduct pilot tests with selected user groups. This phase is crucial for assessing the technology's practicality and effectiveness in real-world applications. Key activities include user feedback, collecting qualitative and quantitative feedback from pilot participants to identify areas for improvement. Real-world applications, testing the technology in various scenarios, such as assistive communication tools for individuals with speech impairments. Iterative improvements, making adjustments to the technology based on user experiences and outcomes from the pilot tests. 3. Full rollout, late 2024. If the pilot tests are successful, Meta will proceed with a full rollout of the thought-to-text technology across its platforms. This phase will involve integration with Meta applications, embedding the technology into existing Meta applications such as Messenger and WhatsApp, to enhance user engagement. Partnerships, exploring collaborations with educational institutions and healthcare providers to broaden the technology's applicability. Marketing and education, informing users about the new technology and providing training on how to use it effectively. Budget allocation. Meta has earmarked a budget of $5 million specifically for the development and rollout of the thought-to-text decoding technology. This budget will be allocated as follows. Research and development, approximately 60% of the budget will focus on research and refining the technology. Pilot testing, 20% will be dedicated to conducting pilot tests, including participant compensation and data analysis. Marketing and education, the remaining 20% will be spent on marketing efforts and educational resources for users. This budget reflects Meta's commitment to not only advancing AI technology but also ensuring that it is done responsibly and ethically. Integration with AI frameworks. The integration of thought-to-text technology with Meta's existing AI frameworks such as the Research SuperCluster will play a pivotal role in the technology's success. Research SuperCluster. The Research SuperCluster is a powerful computing system comprising 16,000 NVIDIA A100 GPUs. It will facilitate efficient training. The supercluster will enable rapid training of the thought-to-text model, allowing for real-time updates and improvements. Data handling, managing the extensive data collection required for training the model, ensuring that the system can handle large volumes of neural data securely. Open source strategy. Meta's open source strategy, as demonstrated with the Llama series, will encourage collaboration and innovation within the AI community. By making the underlying technology accessible, Meta aims to foster a vibrant ecosystem of developers and researchers who can contribute to the technology's advancement. Ethical considerations and user experience. As with any emerging technology, ethical considerations are paramount. Meta is committed to addressing potential concerns related to privacy, data security, and the implications of thought-based communication. Privacy and data security. User consent, ensuring that users provide informed consent for data collection and usage. Data anonymization, implementing mechanisms to anonymize data to protect user identities and maintain confidentiality. Compliance with regulations, adhering to regulations such as GDPR to safeguard user rights. User experience. Accessibility, ensuring the technology is accessible to all users, particularly individuals with disabilities. User training, providing comprehensive training and resources to help users effectively navigate the new technology. Feedback mechanisms, establishing channels for users to provide ongoing feedback which will inform future updates and enhancements. Conclusion. Meta's implementation of Thought-to-Text Decoding Technology in 2024 represents a significant advancement in AI, enabling more intuitive human-computer interactions. Through careful planning, budget allocation, and ethical considerations, Meta aims to enhance user experiences while addressing potential challenges. The successful rollout of this technology has the potential to transform communication, particularly for individuals with speech impairments, and pave the way for more accessible and innovative AI applications across various sectors. The implementation of Meta's Thought-to-Text Decoding Technology in 2024 presents several counterintuitive aspects that may challenge conventional expectations surrounding AI advancements and their implications. 1. Budget allocation versus expectations. Meta has allocated $5 million for the development of this technology. While this figure may seem significant, it is relatively modest compared to the billions typically spent on cutting-edge AI technologies by major tech companies. This raises questions about the scalability and reach of the thought-to-text technology. Many might expect a more substantial investment to yield groundbreaking results, but this budget indicates a focused, perhaps cautious approach to development, suggesting that the company may be testing the waters before fully committing to wider applications. 2. Open source strategy. While many companies are moving toward proprietary models in AI development, Meta's strategy of releasing its Llama series as open source is counterintuitive. The expectation might be that a company like Meta would seek to capitalize on its innovations for proprietary gain. Instead, it is fostering a collaborative environment, potentially sacrificing immediate competitive advantage for long-term community-driven enhancements. This could lead to greater adoption and innovation from third parties, which may ultimately benefit Meta in unforeseen ways. 3. Integration with existing frameworks. The integration of the Thought-to-Text technology with existing AI frameworks like the Research SuperCluster, which employs a massive array of NVIDIA GPUs, suggests a level of synergy that might not be expected. Typically, new technologies are perceived as standalone innovations. However, Meta's strategy appears to be one of leveraging existing infrastructure to enhance the performance and application of new technologies, which could lead to faster development cycles and improved outcomes. For transformative potential versus skepticism, there exists a divide in perceptions about the transformative potential of this technology. While some experts and Meta representatives express optimism about its ability to enhance communication, especially for individuals with disabilities, others voice skepticism concerning data privacy and the potential for misuse of thought-reading technologies. This dichotomy illustrates the tension between innovation and ethical considerations, suggesting that what might be seen as a technological advance could also evoke significant concern about privacy and security. 5. Pilot testing versus full rollout timing. The phased approach to implementation, development, pilot testing, and then a full rollout, contrasts with the typical tech industry practice of rapid deployment. Many might expect a swift rollout to maximize market presence. But Meta's methodical approach indicates a prioritization of safety and effectiveness over speed. This could lead to more robust technology but might also frustrate stakeholders eager for immediate results. 6. Assistive technologies for speech impairments. The primary use case cited for thought-to-text technology is to assist individuals with speech impairments. This focus may seem limited for a technology developed by a major AI player like Meta, which typically seeks to appeal to the broader consumer market. However, this targeted application could redefine accessibility and inclusivity in a way that resonates deeply with affected communities, potentially reshaping public perception of AI's role in society. 7. Ethical concerns versus innovation drive. The emphasis on ethical standards and compliance alongside the push for rapid innovation creates a paradox. Companies often face pressure to innovate quickly, sometimes at the expense of ethical considerations. Meta's commitment to safety and ethical compliance. Despite the competitive landscape, suggests a longer-term vision that prioritizes responsible innovation even if it means sacrificing short-term advantages. In summary, the implementation of Meta's Thought-to-Text Decoding Technology in 2024 embodies various counterintuitive elements that challenge conventional wisdom around AI development. It reflects a complex interplay between cautious investment, open-source collaboration, integration strategies, and ethical considerations, revealing a nuanced approach to advancing technology in a rapidly evolving landscape. The report on Meta's Thought-to-Text Decoding Technology implementation in 2024 highlights significant advancements, phases of development, budget allocations, and integration with existing AI frameworks. However, several important aspects may be overlooked by the general audience, which could have profound implications for the understanding and acceptance of this technology. Here are key points that deserve more attention. 1. Ethical and privacy considerations. One of the most significant yet often overlooked aspects of this technology is the ethical implications surrounding thought-to-text capabilities. As this technology directly interprets neural signals to generate text, it raises substantial concerns regarding privacy, consent, and potential misuse of personal thoughts. Significance: the ability to convert thoughts into text could lead to invasive applications where individuals might be compelled to share their thoughts without explicit consent. This infringement on personal privacy could provoke public backlash and regulatory scrutiny. The discussion around ethical use and privacy standards is crucial, as it will determine the societal acceptance of such technologies. 2. Budget allocation and expectations. The report states a $5 million budget allocated for research and development. While this may seem substantial, it is worth noting that this figure is relatively modest within the broader context of AI development, especially when considering the vast investments made by other tech giants in similar fields. Significance: the limited budget might indicate a cautious approach, reflecting Meta's awareness of the potential risks and ethical dilemmas associated with this technology. This could impact the speed and scope of development, affecting the timeline for practical applications. Stakeholders need to evaluate whether this budget is sufficient to cover the extensive R&D needed for safety and efficacy testing. 3. Integration with AI frameworks. The integration of the thought-to-text technology with Meta's existing AI frameworks, particularly the Research SuperCluster, involves complex computational resources. The SuperCluster's capability is impressive, harnessing 16,000 NVIDIA A100 GPUs. Yet the operational complexity of such integrations often goes unnoticed. Significance: this integration is not merely a technical challenge but also highlights potential bottlenecks in data processing and model training. The success of the technology hinges on the robustness of this integration. Understanding the intricacies of these systems can provide insights into the operational hurdles Meta may face, which can ultimately impact user experience and technology reliability. 4. Applications beyond assistive technologies. The report emphasizes assistive technologies for individuals with speech impairments as a key use case. However, the broader applications of thought-to-text technology could extend far beyond this. Significance, potential applications in education, content creation, and even legal documentation could revolutionize how we interact with information. The capacity for instantaneous transcription of thoughts could enhance productivity tools, streamline workflows, and create new forms of media. Recognizing these possibilities can help stakeholders appreciate the full potential of the technology and advocate for its responsible development. 5. User feedback and iteration. The pilot testing phase to gather user feedback is critical but may be underemphasized. Gathering insights from diverse user groups is essential for refining the technology and ensuring it meets real-world needs. Significance, engaging users in the development process can lead to innovative solutions that address genuine concerns and preferences. This iterative feedback loop is vital for creating a user-centered product. Failure to adequately incorporate user feedback could result in a product that, despite its technical prowess, fails to resonate with or meet the needs of its intended audience. 6. The balance of skepticism and optimism. The report outlines a dichotomy between skepticism regarding data privacy and optimism about the transformative potential of the technology. This balance is crucial but often oversimplified. Significance, a nuanced understanding of both perspectives is necessary for meaningful discourse. Skepticism can drive the development of robust safeguards and regulatory frameworks, while optimism can fuel innovation and investment. Engaging with both sides can foster a more productive conversation about the implications of the technology and its potential societal impact. 7. Open source strategy and community engagement. Meta's open source approach with Llama 2 is a noteworthy aspect that may not receive adequate attention. This strategy encourages collaboration and innovation within the AI community. Significance, an open source model can democratize access to advanced AI technologies, enabling smaller entities and researchers to contribute to and benefit from advancements. This collaborative environment can accelerate innovation and ensure diverse perspectives are represented in the development process. Understanding the implications of this approach can help stakeholders navigate the evolving landscape of AI technologies. 8. Societal implications of thought decoding. The societal implications of thought decoding are profound yet often considered too futuristic for serious discussion. The potential for altering human communication and interaction is significant. Significance, as this technology matures, it could redefine how we share and communicate thoughts, impacting everything from interpersonal relationships to workplace dynamics. Engaging with these implications early in the development process can help prepare society for the changes ahead and promote responsible use of the technology. Conclusion. In summary, the report on Meta's Thought-to-Text Decoding Technology implementation in 2024 encompasses various critical aspects that deserve deeper consideration. Ethical implications, budgetary constraints, integration challenges, user feedback mechanisms, and societal impacts are all pivotal to the successful deployment and acceptance of this groundbreaking technology. By shining a light on these often overlooked areas, stakeholders can foster a more informed dialogue about the future of AI and its role in society. 1. Implementation phases. The implementation of Meta's Thought-to-Text Decoding Technology is structured in 3 key phases: development, pilot testing, and full rollout. Understanding these phases is crucial for comprehending how Meta plans to transition from a theoretical model to practical applications. The development phase focuses on utilizing the existing Llama series for algorithm refinement, while the pilot testing phase aims to assess real-world applications for various user groups, particularly those with disabilities. The full rollout phase will integrate the technology across Meta applications and explore partnerships in education and healthcare. 2. Budget allocation. The allocation of a $5 million budget is significant as it reflects Meta's commitment to research and development while also addressing ethical considerations regarding privacy and data security. This budget not only supports technological advancements but also emphasizes the importance of ensuring that the technology complies with ethical standards, which is vital in the sensitive area of thought-to-text translation. 3. Integration with AI frameworks. The integration of the thought-to-text technology with Meta's existing AI frameworks, notably the Research SuperCluster, is pivotal for its success. The supercluster, equipped with extensive computational resources, enables efficient training and deployment. This integration suggests that the technology is backed by robust infrastructure, which is essential for managing the complexities involved in interpreting neural signals and generating text effectively. For a democratization of AI, a recurring theme across discussions is the potential for Meta's technology to democratize access to AI, particularly for individuals with disabilities. This aligns with broader social goals of increasing accessibility and inclusivity in technology. The emphasis on open-source strategies such as the development of the Llama series further supports collaboration within the AI community, fostering innovation while addressing concerns about monopolistic practices in AI development. 1. The development of the telephone. 1876. Alexander Graham Bell's invention of the telephone marked a significant shift in communication technology. Prior to this, communication over distances relied heavily on telegraphy, which was limited to text messages. The telephone allowed for voice communication, drastically changing personal and business interactions. The development involved numerous phases, from conceptualization, experimentation with sound transmission, and ultimately the establishment of a communication infrastructure that connected people in real time. 2. The launch of the Internet. 1960s to 1990s. The development of the Internet was a multi-decade effort that transformed global communication and information sharing. Initially developed as ARPANET in the 1960s, its evolution included various phases such as the creation of protocols TCP/IP, the introduction of the World Wide Web by Tim Berners-Lee in the early 1990s, and the commercialization of Internet services. This technological revolution has led to unprecedented changes in how people access information, communicate, and conduct business. 3. The introduction of the personal computer. 1970s to 1980s. The emergence of personal computers (PCs) during the late 1970s and early 1980s revolutionized the way individuals interacted with technology. Initially, computers were large, expensive, and used primarily by businesses and research institutions. The development of microprocessors enabled the creation of smaller, more affordable machines like the Apple II and IBM PC. These innovations set the stage for widespread personal computing, leading to changes in work, education, and entertainment, and laid the groundwork for the digital age we live in today. In 2024, Meta is set to launch its Thought-to-Text Decoding Technology, a groundbreaking advancement in artificial intelligence that enables users to communicate with AI systems using their thoughts instead of traditional input methods like typing or speaking. This innovative technology is anticipated to enhance user interaction significantly, especially for individuals with speech impairments, by allowing direct conversion of thoughts into text. Key phases of implementation. 1. Development phase. Early 2024. Meta will utilize its existing Llama series, particularly Llama 2, to refine the thought-to-text technology. A dedicated budget of $5 million will be allocated to enhance algorithms and improve the model's ability to interpret neural signals accurately. This phase will include comprehensive testing to ensure reliability and effectiveness in generating text from thought. 2. Pilot testing. Mid-2024. Select user groups will participate in pilot tests to evaluate the practical application of the technology. Feedback gathered during this phase will drive further enhancements in the model's performance and user experience. Applications will target assistive technologies for individuals with speech impairments, improving their communication capabilities. 3. Full rollout. Late 2024. Following successful pilot testing, the technology will be fully integrated into various Meta applications, enhancing user engagement and accessibility. There may also be potential for partnerships with educational institutions and healthcare providers, broadening the technology's reach beyond Meta's ecosystem. Budget allocation. The $5 million budget reflects Meta's commitment to advancing AI technology while addressing ethical considerations including privacy and data security. The funds will focus on research and development to optimize the model's capabilities and ensure compliance with safety standards. Integration with AI frameworks. The integration of Thought-to-Text technology with Meta's existing AI frameworks, particularly the Research SuperCluster, will facilitate efficient training and deployment. The supercomputer powered by 16,000 NVIDIA A100 GPUs will support the computational demands necessary for training the Thought-to-Text model and handling extensive data. Future outlook and predictions. 1. Democratization of AI. The Thought-to-Text technology is expected to democratize access to AI, particularly benefiting users with disabilities. This aligns with Meta's broader vision of making technology accessible to all. 2. Open source strategy. Meta's approach to open source development, as demonstrated with the Llama series, is likely to foster collaboration and innovation within the AI community. This strategy could lead to a surge in third-party development, enhancing the technology's capabilities and applications. 3. Real-world applications. Beyond assistive technologies, the technology's potential applications in education, healthcare, and various industries could drive significant advancements in how AI interfaces with humans. This may lead to new business models and revenue streams for Meta. 4. Challenges and concerns. Despite the optimism, challenges such as data privacy, the potential for misuse, and the reliability of thought interpretation will need to be addressed. Skepticism regarding the effectiveness and scalability of the technology could impact user adoption. 5. AI integration in daily life. As the technology matures, it may become a standard feature in everyday devices, leading to a shift in how people interact with technology. This could pave the way for more intuitive, human-centered AI applications. 6. Ethical considerations. The implementation of this technology will require careful navigation of ethical concerns, including the implications of reading and interpreting thoughts. Establishing guidelines and regulations will be essential to ensure responsible use. Conclusion. Meta's Thought-to-Text decoding technology represents a significant step forward in AI interaction, combining advanced neural signal interpretation with practical applications. As Meta progresses through the key phases of development, pilot testing, and rollout in 2024, the technology holds the potential to transform communication, particularly for those with disabilities. However, the journey will entail addressing ethical concerns and ensuring responsible deployment to harness its full potential while safeguarding user privacy and security. The landscape of AI interaction is poised for a revolutionary change, one that could redefine user experiences across various sectors.